Now that we have the state modeled for our authentication screen, we can start thinking about the view model that will be used to manage that state and provide a way to orchestrate that to the user interface. We'll start here by creating a new class called Authentication View Model. This is going to need to extend from the Android View Model class. The view model is going to need to hold a reference to the state of our screen. So for this, we're going to utilize state flow. This allows us to create a state holder observable flow that will emit the default state we provide to it, along with any updates that occur during its lifetime. Here, we'll create a new mutable state flow reference, providing a reference to our authentication state class as a default value for our state flow. With this in place, we now have a state flow reference that is holding a reference to our authentication state, initializing it with a new instance of the state class and relying on the defaults that the constructor provides. With this state now in place, we need to start thinking about the different ways in which it can be manipulated. Whenever something is changed within our UI, such as text being edited, button pressed, we want to update the state within our view model so that the observing UI can reflect those changes. For when this is the case, we're going to model some events that could be triggered in our composable UI, and in turn, these events will be used to manipulate the state within the view model. This allows us to have a single way of our composable UI communicating with the view model, rather than needing to pass the entire view model or many references to separate functions, which could be used to trigger state changes. Instead, we can pass a single function reference to our composable UI, which can be used to trigger these events in the view model. For these events, we're going to need to define different types that could be triggered, so we'll go ahead and create a new sealed class to represent these. We'll call this Authentication Event. With this sealed class in place, we can start to think about using it to represent the different events that can occur within our UI. We're going to start by handling the scenario where the authentication mode can be toggled between the sign up and sign in modes. For this, we'll create a new event called Toggle Authentication Mode. This doesn't need to take any arguments, so we can simply use an object here, and it just needs to extend from the authentication event sealed class type. With this event in place, this can now be triggered from our composable UI to cause a state change in our view model. For this to happen though, we need to write this logic inside of our view model. We'll start here by creating a new function that will be used to flip the current authentication mode, switching it between sign up and sign in. We'll call this function Toggle Authentication Mode. What we want to do here is take the current value of the authentication mode and then switch the value in our state based on this. So if the current authentication mode is equal to sign in, we'll flip this to sign up, and otherwise it's going to become sign in. We then use the current value of our UI state, calling the copy function to update the authentication mode, leaving the rest of the state values intact. Now that we have this function available to handle the state change of the authentication mode, we need to go ahead and add support for triggering it from outside our view model. For this, we'll add a new function to our view model that will take a reference to an authentication event. We'll call this function handle event, add the authentication event argument, and then use a when block to trigger the corresponding function based on the authentication event type. While this looks minimal right now, we'll be adding to this as we go throughout this video. With the authentication mode toggle in place, we can start thinking about the other events that we want to trigger from outside our view model. If we take a look at the authentication state model, then we can see the other pieces of state that we need to manipulate. Two key pieces of this state are the email address and password. These will represent the data that has been input by the user and will need to be reflected in our state whenever they change. For this, we're going to add two more events to our authentication event sealed class. These will be called email changed and password changed. Now, each of these events are going to be classes, as they each need to take an argument in the form of an email address and a password. Note that these are non-nullable, as they are going to be represented by the input that has been done by the user. And this is either going to be a string value or an empty string. These will allow the UI to trigger these events whenever the input of these fields changes. But for that to be possible, we need to go ahead and implement some functions in our view model that allow this state change to be reflected. We'll start with a function, update email, that will simply be used to update our state reference with the provided email address. This will take an email argument and use the copy function on the existing state value to update the email. And when it comes to the password, we're going to do the same thing. We'll create a new function called update password that takes a password argument in the form of a string and updates the current value of our state reflected by this new password change. We're then going to update our handle event function to handle each of these new event types. So when the email change is triggered, we'll call the update email function, and when password changes triggers, we'll call the update password function. However, when the password is updated, we'll always want to update the validity of the password requirements. For this, we're going to create a new list that consists of password requirements for which we'd add references to for the requirements that have been met. This list can then be set on our state so that the UI layer can be aware of the requirements that have been satisfied. When building this list of requirements, we'll need to keep a couple of constraints in mind. If the password length is greater than 7, we're going to add the requirements for 8 characters, which means that the requirement has been satisfied. If any of the password characters are uppercase, we'll then add the capital letter requirement, meaning that that has been satisfied. And finally, if any of the password characters represent digit, we'll add the number 1. With this intact, we now have a list that represents the requirements have been met, and we can update the password requirements value in our state within this copy function. With these email and password functions in place, these can now be triggered via an event whenever the input is changed. Now that the user can toggle between authentication modes and enter their account credentials, naturally, the next step would be to allow the UI to trigger authentication. For this event, we don't actually need to send any data from the UI. This is because we have the email address and password already reflected within our authentication state, so these can just be retrieved from there. We're going to add a new event here called Authenticate, and this is simply going to be an object, which we don't need to pass any data for. With this in place, we can next add a function that this event will be used to trigger. For this example, we won't actually be triggering a network request, but instead we'll be responding to the authentication request in the UI and reflecting this via the loading property within the authentication state. With this function in place, we now have something that will simulate the network request taking place within our application. With all of this in place, we now have a view model that can handle the different required state properties and events that allow the user to enter their credentials, toggle between authentication modes, and then proceed with triggering the authentication process. However, we still have a final property for our authentication state to handle, and that is the error. This property defaults to null within our state, so in that case, our UI won't need to display any kind of error. But when this is not null, the UI will represent the error in some way, and then also provide a way for it to be dismissed from view. So that we can simulate this scenario and then manage the expected state, we will modify our authenticate function. After we have emitted the loading state, we'll add a delay to simulate a network request, followed by removing the loading status and emitting an error message in the authentication state. Again, we're not performing a real network request here. This allows us to simulate an error in the network request so that we can build the UI for this over the course of these videos. You'll notice here that we're hopping between coroutine dispatchers. While we're not making a real network request here, this is to simulate a real scenario and ensure that the asynchronous work and live data emissions happen using the expected dispatchers. With this in place, the error will be emitted as part of the authentication state for the UI to reflect. While we haven't created the UI yet, this error will be composed in the form of an alert dialog. That means that we will also need to be able to dismiss the dialog. To support this, the error of our state will need to be cleared so that the UI is recomposed and the alert dialog is not part of the composition. So that this can be cleared from our state from our UI, we're going to add a new authentication event called error dismissed. This is going to be an object that doesn't need to take any data, except it just needs to simply extend from the authentication event type. With this in place, we are now able to receive error dismissal events from our UI layer, meaning that we also need to implement this state change for when this occurs. Here, we'll create a new function called dismiss error and simply set error property in our state to null using the copy function. The last thing to do here is then trigger this function whenever the error dismiss event is triggered. With all of this implemented, we are now managing the state of our authentication screen and providing the required entry points for our UI layer to manipulate the state based on user interaction. Our view model is now ready to be plugged into composable UI, which we're going to create over the course of the next videos.